Capacity is a measure of the amount of liquid that you can fit into a container. To work out the capacity of a container, it's usually best to work out its volume in cubic centimetres first. So this shape here is a pyramid turned upside down. So the formula for the volume of a pyramid is V equals 1/3 times the area of its base times its height. So that means 1/3. Now the shape of the base of this is a square. So to work out the area of a square, it will be, in this case, 28 centimetres times 28 centimetres is the area of the base, times the height is 50. You can check me on the calculations here. I've done beforehand, so it works out to be 13,066.67 cubic centimetres. But we will ask for the capacity. Now capacity is always, it's a measure of how much liquid you can put inside a container, and liquid is measured in litres. Now it's useful to know these conversions at the top of the page, but you can see that every litre takes up 1,000 centimetres cubed. Here we've got 13,000 centimetres cubed, so it's going to be a bit over 13 litres. Or, if you like, to change from centimetres cubed into liquid in litres, you're going to divide by 1,000. So that means the capacity is equal to cubic centimetres. That's 1,000 cubic centimetres make up a litre. Divide by 1,000 means move the decimal place 3 positions. 13.066 litres will fit inside there. This is sort of a hemispherical bowl, so it's half a sphere. The formula for the volume of a full sphere is V equals 4/3 times pi r cubed. But we here have only got half a sphere, so we're going to get that, our answer to that, and times it by half. So we've got a half, or 0.5, times 4/3 times pi, 3.142, times by the radius cubed. That means 15 times 15 times 15. Okay, you can work it all out on your calculator. Works out to be 7,069.5 centimetres cubed. But remember, there's 1,000 centimetres cubed which make up a litre. So if I was to divide this by 1,000, move the decimal place 3 decimal places, or do it on your calculator if you have to, the capacity will be 7.069 litres. Got another question down the page. I'm just going to pause for a moment. One of the first things I've noticed when I read through this question was that we've got some different units here. We've got this measured in centimetres and this measured in metres. Beware of questions like this. Always before you start, make sure you're working in consistent units. I think it'd be best here if we worked in centimetres. So I'm going to change that 1.2 metres into centimetres, times it by 100, 1.2 times 100. So that really is 120 centimetres long for 1.2 metres. Now the 3 questions asked here. First you have to work out the capacity of the trough if it was full right to the top. Now to do that, you can see it's a prism in shape. It's got a cross-sectional shape of a trapezium and then sides which just come up all round from it. So that means that the formula for its volume is going to equal the area of its cross-section times its height. But we need to know the area of this trapezium before we go too much further. Now, the formula for the area of a trapezium, if you were to look back, is something like this. The area is equal to a half times the sum of the parallel sides multiplied by the distance between them. Half times A plus B times H, if you were to look at it in the form of a formula. Another way of thinking of it is it's the average of these parallel sides times the distance in between them. We can do that on our calculator, and you'll find that the area of this shape here works out to be 1,140 centimetres squared. Now we can go to our volume formula. We know the area of the trapezium, the area of the base, is 1,140, so we just times it by the height or the depth of the shape, 120, give us an overall volume of 136,800 centimetres cubed. Obviously that's a large number, but we're only talking about centimetres cubed. We were asked for capacity, that's a measure of liquid size, so we really need to answer in litres. 1,000 centimetres cubed in a litre. So if we were to divide this by 1,000, move the decimal place 3 positions, the volume, or the capacity of it, would equal 136.8 litres, would fit inside there. Part B of the question says find the amount of water in the trough when it's filled to half its height. So what we're doing is we're looking at this shape here, which is also a smaller trapezium. I guess if it's half its height, it's only going to be 15 centimetres in height. This base will still be 26. What about this distance here? Well, what I'm thinking is if that's halfway up the trapezium, that distance from there to there is going to be the average of 26 and 50. If you were to average 26 and 50, you'll get that distance here. So 26 plus 50 divided by 2 for the average. Don't forget to press equals after it's on that top here. 38 centimetres is the distance across the top of our smaller trapezium. Now, if we want to find out the area of that trapezium, it just becomes like this last question we've done here. Work out the area of that trapezium. Half times A plus B is 26 plus 38 times by 15 equals, and you can do the calculations yourself, it works out to be 480 centimetres squared is the area of that trapezium. And to work out the amount of water in there, volume equals the area of the base, which is our smaller trapezium, times the height will still be 120. The volume when it's filled to half is equal to 57,600 centimetres cubed. We really need that in litres because it said amount of water. So 1,000 centimetres cubed make up a litre. Divide by 1,000 equals 57 litres of water. 57.6, should I say, litres of water. And that's just about answered. Oh, one thing you might notice is it's filled to half its height, but the that's 57.6 is a bit less than half of 136, isn't it? And you'd expect that because the shape is tapered out. So this bit here is going to have more than, even though it's filled to half its height, this bit here is going to have more volume than this bit here. Little last question says, how much would that water weigh? Now that's pretty easy, because every litre of water weighs 1 kilogram. That's one of the beauties of the metric system. It's sort of designed so that computations like this can be easy. A litre of fresh water weighs 1 kilogram. We've got 57.6 litres here, so the weight of water equals 57.6 kilograms.